Hello friends, today we are going to discuss about the basics of tool engineering. This is our fourth session over the basics of tool engineering. Myself, Jay Derle, lecturer in mechanical department, KK Polytechnic. So in this session, we are going to discuss about the types of chips. So first of all, we will discuss the chip formation. So we know that during any machining processes, we get the chips when we apply the force or the workpiece with the help of tool. So this chip produced during the metal cutting depends upon the machining condition and the type of material which is to be cut. So here we have some major factor and some minor factor which will influence the type of chip produced during the machining processes. So we have here first some major factors. So first major factor is property of material. Second one is depth of cut, feed rate, effective rake angle, cutting speed of the tool, and the type of cutting fluid and its quantity. So these are the some major factors which will creates or which will influence the type of chip produced at the time of machining. And there are some minor factors which will also influence the type of chip produced during the machining processes. So first is the surface finish of tool, second one is coefficient of friction between the tool and chip, third one is temperature created during the machining, have some effects over the chip formation, but it will create the less effect as compared to these major factors. So this is what about the chip formation. So basically here the chip formation depends upon the type of material and these major factors. So first of all, we will discuss here the types of chips. So whatever the cutting condition can be, the chips are three types. First one is discontinuous chips, continuous chips with built-up edge. So these are the three types of chips. So here we have three diagram. First diagram represent the continuous chips, second diagram represent the continuous chips, discontinuous chips, third diagram represent the continuous chips with built-up edge. So here we get, in first diagram we get the continuous chips and material is ductile material. Here workpiece material is ductile material. In ductile material we get the continuous chips. In second diagram represent the discontinuous chips. So here workpiece is made up of brittle material, then we get here discontinuous chips. When we apply the force over the brittle material with the help of tool, then we get here discontinuous chips. And third one represent, this diagram represent the continuous chips with built up edge. When we apply the force over the ductile material with the help of tool, but during the machining processes there is a high pressure and temperature, then in that condition there is a continuous chips with built-up edge will form during the machining processes. So here we have the built-up edge over the tool as well as over the workpiece material. So this is what about the types of chips. So first of all we will discuss about the discontinuous chips. So this discontinuous chips is occurred in brittle material when we apply the force over the brittle material with the help of tool. So this brittle material has the lack of ductility property, and because of that lack of ductility property, it will fails in brittle fracture manner along the shear zone during machining processes, and due to this it produces the small fragments of chips, and that chips is called as discontinuous chips. So these chips breaks up into the small fragment, so there is a less friction created between the tool and the chip, and resulting we get the better surface finish of workpiece, and these chips are convenient to collect, handle and dispose of. So here this diagram represents the discontinuous chips, and the workpiece is made up of brittle material. When we apply the force over the brittle material with the help of tool, we get here discontinuous chips because of the brittle material has lack of ductility property, and during the machining processes this brittle material fails in brittle fracture manner along the shear zone, and it will produces the small fragments of discontinuous chips. So here we have some discontinuous chips in ductile material also, but there are some conditions under which the discontinuous chips are formed in a ductile material. So first condition is when we put the large chip thickness ratio in case of ductile material, then also we get here discontinuous chips. Second one is when we put the low cutting speed for a ductile material, again we get here discontinuous chips. Then third one is cutting with use of cutting fluid for a ductile material, again we get here discontinuous chips. And when we put the small rectangle for the tool for ductile material for the operation or cutting operation of ductile material, then also we get here discontinuous chips. So here we can say that for brittle material we get the discontinuous chips, but under some condition for ductile material also we get here discontinuous chips. So next we will discuss about the continuous chips. So here for getting the discontinuous chips we require ductile material. In ductile material there is a longer continuous chips are produced due to the plastic deformation. So here we have ductile material. When we apply the force over the ductile material with the help of tool, there is a plastic deformation and we get the longer continuous chips, and because of this longer nature the chips are most desirable. So these chips are most desirable, and here we get the stable cutting, and resulting we get here the good surface finish of workpiece. But on the other hand, there is one disadvantage of this type of longer or continuous chips is that because of this longer nature it will form a curly shape, and when this curly shape breaks it may injure the operator. So to avoid this curly or to avoid the injury of operator, we need to put here chip breaker. So the function of chip breaker is to reduce the curvature of chip and thus break it. So this is what about the function of chip breaker. So this type of chip remains in contact with the tool face for a longer period, resulting in more frictional heat. So when this because of this longer nature of continuous chips, it will creates the more frictional heat. So this is what about the continuous chips. So here some condition also help for production of continuous chips. First we need to put here small chip thickness, then high cutting speed also creates the continuous chips, large rectangle also creates the continuous chips, and reducing the friction of the chip along the tool face will also create the continuous chips. So these are the some conditions under which we get the continuous chips. So here we have diagram. This is our we can say that this is our ductile workpiece material. When we apply the force over the ductile material with the help of tool, then we get here the continuous chips, and the nature of this continuous chips is longer continuous chips, and because of it will forms the curly nature. And one disadvantage is that due to the curly nature, when it will breaks it may injure the operator. So for that purpose we need to put here chip breaker. So this is what about discontinuous chips. Then we will see the continuous chips with built-up edge. So here condition for ductile material, when during the machining operation for ductile material, when there is a high local temperature and extreme pressure in the cutting zone, and also high friction in the tool chip interface, and it may cause the welding of the material or weld to the cutting edge, then to form the built-up edge. When the high local temperature and pressure during the cutting operation, it will creates or it will cause the work material weld to the cutting edge of the tool, and it will form the built-up edge. And when thus here the successive layers of work material are added over the built-up edge, and then it becomes larger and unstable, and it breaks up, and part of is carried up with the help of tool face, and remaining is left over the workpiece. So here during the machining operation, when there is a high pressure and temperature, at that time the material is added or weld over the cutting edge of the tool, and because of that when the successive layers are added over the built-up edge, then it becomes larger and unstable, and it breaks up, and the partly welded material is carried with the help of tool, and remaining is left over the workpiece. So here we have the built-up edge over the tool, as well as here we have the built-up edge over the workpiece. So the nature of this built-up edge during the cutting operation, first it will increases, then again it decreases, and then again it increases, and this cycle will creates the vibration and poor surface finish. So here because of this nature or this cycle will create the vibration, and we get the poor surface finish of workpiece. So this is what about the continuous chips with built-up edge.